Okay, we're going to apply the method with P of t equal this, G of t equal this. So your equation is just this. There's your P of t matrix multiplied by y. There's your non-homogeneous part, e to the negative t0, and of course that's your y prime. Okay? So your homogeneous equation is just this. And we start with the homogeneous equation, because if we don't have the homogeneous equation, we aren't going to have a psi matrix. Right? And, you know, in the end, what you have to do is you've got your solution, derivative of your solution is the inverse of the psi matrix times your G of t. So once you get the psi matrix, it really just comes down to multiplying it, inverting it, and then multiplying it by this. And then integrating what you get. Okay? So, how do you solve the homogeneous equation? I know you've been concentrating on second order equations, okay?
You assume that y equals ae to the lambda t times your ab, or your vector.
Yeah.
That's
pretty good. And you don't need the constant a. I've used it sometimes. But since you're just trying to find a fundamental set, you know any multiple of your solution is still going to be a solution, right? So you don't need the a. And if you have it, it's going to divide out anyway. So I've used it, but we can really dispense with it because, as you know, if you've worked a few equations, it sounds like you have since you gave me a good answer, okay, that we don't need the a. Doesn't hurt. Going to divide out whether you have it or not. So you might as well not have it. So we assume solution. And we'll just use A, B there.
Data's already there, sitting there now free, so why don't we run it?
Column vector, it's a two-dimensional system. System of two equations, essentially. Okay? And what do we get? Well, go through the details, and you end up with characteristic equation, which is going to be what? 2 minus, well, we'll do it. Determinant 2 minus lambda 1, 1, 2 minus lambda, which is 4 minus 4 lambda plus 3. And it's 4. What am I doing?
You got your lambda squared.
It's 3 minus 4 lambda plus lambda squared. Okay? And then lambda squared minus 4 lambda plus 3 equals 0. Lambda equals 4 plus or minus the square root of 4 over 2, which is 2 plus or minus, and it's negative 4. 2 plus or minus I believe. Okay?
There means they could have been the same. Everybody see why 0 means they could have been the same? Because when you subtract
Then you take
0, they're
these,
the same. Right?
plug them back in here,
Next thing
and
is
see what your values of lambda
the interval contains
are. See what your values of A and B have to be.
How do you get a negative discriminant?
confidence that the difference
Actually, you
between them
don't.
was negative, meaning that one was.
You got an e to the minus t. Okay.
You see how a confidence interval in this particular scenario.
2 plus or minus 1. I wanted a negative there. But I don't have any sines or cosines, so I don't know why I wanted a negative. Okay? So I wanted one, so I invented one, but really it's, if you do it carefully, which I wasn't doing, you get this. Okay? Okay, well, see what your eigenvalues are. I mean, see what your eigenvectors are. You got to find your ABs that match the two eigenvalues. So you got lambda 1 equals 3, lambda 2 equals 1.